Welcome to solverfy.
Question 99 is a rather lengthy question that requires you to include in your calculations concepts associated with limiting reactants. Ultimately, it wants you to determine the silver ion concentration after a solution containing silver nitrate has been mixed with a solution containing sodium thiosulfate, forming the precipitate or forming the complex ion silver thiosulfate. So after a reaction has occurred, we will have some silver left over and some thiosulfate left over according to this equilibrium. However, before understanding equilibria, we would assume that the reactant that produces the least amount of product would be the limiting reactant and consumed completely. And we still need to include some of this understanding in solving this problem. The Kf expression then for this equilibrium would be as shown here, the product concentration of the complex ion divided by the reactant concentrations, each raised to their coefficient, and that is equal to 4.7 times 10 to the 13 as given in the problem. So, how I would approach this problem is to first determine the limiting reactant in the traditional way, assuming this reaction goes to completion. And it goes pretty darn close to completion because it has a very large equilibrium constant. So if we start with 25 milliliters of the silver nitrate solution at 0.44 molar, we can convert the 25 milliliters into liters, multiply this by the molarity of the silver nitrate solution to get the moles of the silver ion. Then we see that 1 mole of silver ion produces 1 mole of product. So this will tell us now the moles of product that can be created if all of the silver were consumed. Let's do the same thing now with the thiosulfate. We also have 25 milliliters at a concentration of 0.57 molar. So we'll take our 25 milliliters, convert it to liters, multiply by the molarity to get the moles of the thiosulfate, and then recognize that 2 moles of thiosulfate make 1 mole of product. This would then be the moles of product that could be produced if all of the thiosulfate reacts. We see that it is significantly more than the amount that can be created with the silver. So silver ends up being the limiting reactant. This is the first part of the problem. We will assume then that silver, before we carry out our equilibrium calculation, is completely consumed. If silver is completely consumed, then there must be a concentration of thiosulfate that is left over. We can calculate the concentration of thiosulfate that is left over by taking the volume of thiosulfate multiplied by its molarity, similar to what we did here, to determine the moles of thiosulfate we start with. And then we will subtract off the moles of thiosulfate that reacts, which will be equal to the moles of product that we form from the silver multiplied by 2, because we need 2 thiosulfates for every mole of product. So again, this is the moles of thiosulfate we start with, the moles of thiosulfate that react in order to make this amount of product. We then divide that by the new volume. We mix 25 milliliters of each solution together, so we now have 50 milliliters, or 0.05 liters. And we get a final thiosulfate concentration after the complex ion has formed and all the silver has been consumed of 0.241 molar. So if we go back now to the Kf expression and rearrange it, we can solve for the silver concentration, recognizing that because an equilibrium is occurring, it truly is not 0. The silver concentration then will be equal to the complex ion concentration divided by Kf multiplied by the thiosulfate concentration squared because of its coefficient 2. Well, the amount or the molarity of the complex ion that formed will be equal to the moles of the complex ion that forms from the limiting reactant silver divided by the new volume. This is the concentration of the complex ion. We divide that by Kf, which is 4.7 times 10 to the negative or positive 13, and then we multiply that by the thiosulfate concentration that we determined after the reaction had occurred squared. This will give us a silver concentration of 8.1 times 10 to the negative 15 molar.